So here we have a ladder that is 12 that is 12 feet long, and it's leaning against this wall right here. So this is the wall. And the distance from the wall to the base of the ladder, we call that X. The distance from the ground to the top of the ladder, let's call that Y. And so as the base of the ladder moves away from the wall, the height of the ladder also drops. And so let dx dt be the rate of change of x. That's the rate of change of how fast the base of the ladder is moving away from the wall. And let dy dt be the rate of change of the height at the top of the ladder here. And so we like to know how the two rates related. And so the ladder is 12 feet long. And so we call this distance right here x, and we call this distance right here y. So y represents the height here, and then x represents the distance from the wall to the base of the ladder. And so they form a right triangle. And so we have x squared and then plus y squared is equal to 12 squared, which is x squared, and then plus y squared, and then equal to 144. And so this is the equation relating dx dt and dy dt. And the negative here makes sense because as the x moves away from the wall, as the base of the ladder moves away from the wall, the height, the top of the ladder also drops. And now suppose we are given that the rate of change of x with respect to time is 2 feet per second. We'd like to know what is the rate of change of y at the instant when y is equal to 7 feet. And so right now the top of the ladder is at 6.3 right here. And so suppose we so we like for this to be 12. We like for this to be 7. So when the height comes down to 7 right here, at that time, at that instant, what is the rate of change of the height. And so we know from here so if y is 7, then we get 7 squared. And so now we get x squared plus 49 is equal to 144. And so x squared is equal to 95. So subtract 49 from both sides. And so we get x equal to the square root of 95. And then we want to find dx dt, dy dt. So we're given that dx dt is 2 feet per second, and then at the instant when y is 7, then right here we get the square root of 95, and then solving for dy dt, then we get negative 2 divided by this. And this comes out to be about 2.7848. And this would be feet per second. And so at that instant, the height or the y distance is decreasing at a rate of 2.7848 feet per second.